Hello everyone. So today we are going to see the word break problem. It is marked on Leetcode as a medium level problem, but if you go on the GFG portal, the same problem is marked as hard. So let's try to see. First of all, let's jump into the problem statement and see what they are trying to say. So given a string S and a dictionary of strings, word dict, return true if S can be segmented into space separated sequence of one or more dictionary words, and a note is given that the same word in the dictionary may be reused multiple times in the segmentation. So this is more or less similar to the coin change problem that we had done earlier. There also we were given some specific set of coins, and the same coin could be used more than one time, and we were to generate a given target. So it is more or less similar. Let's try to see with an example how this is working. So in the first example, they have given us a string lead code. So let's try to see. So our given string is leaf code, and words are given as we have two words. One is lead and other one is code. So clearly this string can be broken down into lead plus code. So in this case we need to return true. Another example is they have given apple, pen, apple, and the words that we have are apple and pen. So again, you can break this into apple plus pen plus apple. And in the last one, there is a cats and dogs, and the words are cats, dogs, and so there is no way that you can break this particular string into a set of words which are made out of this particular dictionary. So, so this can also be this problem can be solved very easily using dynamic programming. So first of all, let's try to jump into the intuition of how we will go about this problem. So going back to that coin change problem where we had, I'm just trying to relate this to a previous problem. So there we had a target, for example, 11 if I remember correctly, and we had coins 1, 2, and 5. So what were we trying to do over there? We were just simply going by in this list of coins, trying to pick each coin, and then we were trying to see that, for example, if I pick 1, is 10 possible? In the second option, I was trying to pick the coin 2, then I was trying to see if 9 is possible, then I was trying to pick 5, and then I was trying to pick 6, and so on and so forth. And somewhere along the line, if any of these branches turn out to be true, then it means that we can create this overall result. Similarly, we have to do same thing over here. So now let's take the current example again. So our string here is lead code, and we know that the possibility of the words that we can use are only these two. One is lead and the second one is code. So now we just comparing with the coin change problem, we just need to pick words one out of one out of this possible list of words and try to see if by picking one of the words, the rest of the string will be possible to be broken in a similar way or not. I'll try to explain this. For example, let's say I break this string into two parts, S1 and S2. And if I now check the combination of this string, let's call it as S. I've broken this string into two parts, S1 and S2, and I'm now trying to see if this S2 is equal to any of the words in this set. So for example, let's say I first pick the word lead, and I have broken this string somewhere around here. So how we are going to break the string, that also we will cover. But right now, let's assume that I have broken the string at between T and C. So now I have two parts. S1 will be lead, S2 will be code. Now, if I'm comparing S2 against Leet, obviously code is not equal to Leet. So this is not going to serve our purpose. Then I will go to the next word, which is code. Now code is equal to code. These two things are similar. So I know that at least one of the words out of the possible words that I have is a suffix of this string. And that if once this is established, if I just find out if rest of the string is possible, if it is possible to break rest of the string in the similar manner, if that comes out to be true, then my overall string can also be broken down using the list of these possible words. So what I have done is I took the string s, I broke it into two parts, s1 and s2, and then I checked whether s2 is equal to any of the possible words. If that is the case, I just need to ensure that s1 is also possible to be broken up, is also able to be broken down. If I can do this, then it means that overall my string s can also be generated using a combination of these words. So if I try to write a pseudocode for this, then it will become more clear, and it will also help you understand how we are breaking our word. So our inputs were, first of all, let's try to write our inputs. Inputs are, there is a string s and there is a list of words. Cool. So what I am going to do, I just basically for any string s, but I need to do pick a word from this list, then check if word is suffix of s. If not, if this is false, then we simply go to the next word and check again. Because if the current word is not a suffix, then basically we cannot consider the current word. We need to check second word. Basically, like it was the case, there were two words, leet and code. If leet is not a suffix of my string, then I will check with code, and vice versa. But if it is true, then it is a possibility that the remaining word might be possible to be represented in the same fashion. Then we just need to see, is the remaining string, we can say, representable in the similar fashion. Then again, if this thing is true, then yes, s should also be true. The result for s should be true. If that is not the case, then again we will go to the next word. Cool. So yeah, this is overall how we will be proceeding. Then there will be a couple of edge cases or base cases that we will need to ensure. So for example, in the coin change problem as well, we were doing this, that whichever coin we were picking, we had to ensure that it is, it should always be either less than or equal to the total target that we are considering at the moment. In the similar fashion, here also we will need to ensure that whichever word we are picking, its length should be at least smaller or equal to the current string length that we are considering. So we will be making a dp table here as well. It will also be one dimensional in size, and its size will be length of string plus 1, and y plus 1, that also I will explain. So basically our cell, each dp cell is going to represent whether string of length I can be represented like this or not. Based on that, it will have true or false. This will be a Boolean array. Now dp0 will be true because a string of length 0 can always be represented by using we will basically consider that if the length of the string is 0, it can be represented using that set of words, and based on that we are going to build up our rest of the dp table in a bottom up fashion. So here also we will build up in the bottom up fashion only. And once we jump into the code, you will be able to relate like how this is like more or less similar to the coin change problem itself. And apart from that, we will need a utility to check whether a given string, utility for checking suffix, basically just to see if a given word is a suffix of the current string that we are considering or not. So let's jump into the code and try to see how we will go about this. So first of all, we will create a dp table which will be equal to s dot length. Its size will be s dot length plus 1. By default, everything will be initialized with false, but just for the length 0, we will initialize it with 0. Cool. So now what we will do, we will start from length 1. This I will represent the length of the current string that we are considering. It will go until length of the string, then I plus plus, then we'll add comment. I is the length of current string to be considered. Cool. Then what we are going to do, we are basically just going to iterate over the list of the words that we have. So we will say word in word dictionary. Here we will need to use some utility to check whether this word is suffix for string of length I or not. We will add the code for this, but right now let's just see our rest of the logic. So if this is the case, first of all, let's get the length of this current word as well. It will be useful for us. So if we have established that current word is a suffix of string of length I, we just need to ensure that the remaining word. So what will be the remaining word now? If I was considering a string of length I and I have matched it with a word of length which is in we have stored in this variable, so we just need to ensure that uh, dp of I minus length. If this is true, then I will set dp of I to true as well, and I will break. Otherwise, if this fails, if either this is not a suffix or this rest of the word is not, we are not able to break the rest of the word in the similar way, then we will keep continuing and keep trying other words. And in the end, after this point, our db table will be build up. At this point, it will be populated, so we will just return dp of s dot length. So now everything is done. We just need to write this utility, which basically needs to ensure that the current word is a suffix or not. So let's try to write the logic for that also. Let's call it as is suffix. So what it will take as input, it will take as input string number 1, string number 2, which will be our word that we are matching against, and also we somehow need to pass the index value as well. So let's call it as end. I'm calling it as end. So our s1 is the string under consideration, and s2 is the word that we want as suffix. Cool. And ending at index end. So this index also we will pass from here. So let's try to call this function here is suffix. So our string is named s, then we are matching it against word, and then what to pass as the index. So basically for length I, the last index of that string will be I minus 1. So this is it. Now let's just try to populate this function. Cool. So we can actually start matching from the last indices of both the strings. So we know that string s1 is ending at index end. For string s2, we can initialize a variable. Let's call it as I is equal to s dot length. Now until I is greater than equal to 0 and end is greater than equal to 0, and both these values have the same, both these indices have the same character. S1 dot end is equal to s2 dot caret I. We will decrement end and we will decrement I. So these restrictions that we have put in place, they will help us in ensuring that we are not running outside the current string that we are considering. Basically, it will also ensure that condition that I was earlier talking about, that the current word, whichever we are considering, it should always be at least smaller or equal than the length of the string that is under consideration. So these two things will basically ensure that. And in the end, if s2 is a suffix of string s1 ending at index end, then in the end I the variable I should have like exhausted completely. S2 string s2 should be exhausted completely, so its value should be minus 1. So we can just check if I is minus 1, that this then string s2 is a suffix of s1, otherwise not. So we have just returned that thing. Now everything is in place. We can just try to see if this succeeds or not. So I'm clicking on run. Let's see if this succeeds. Okay, so cool. And there is a compilation error. We need to write return. Let's try again. Okay, so it is saying that string index out of range. We have missed something. Let's see what we have missed. Okay, so we have made a mistake that we initialized I with the length itself, but it should be the index value, so minus 1. Let's try to run again. Okay, it's failing for a couple of places. Let's see what we have missed. Let's see what we have missed. Okay, yeah, so this dp table was actually storing basically a dp of I was storing the result for a string of length I, but we have not actually gone till the very end. We have just gone to the last index. So let's try now. Yep. So the basic cases are passing now. So basically we just missed this thing that this should be going to the length, not just the last index. Now let's try to submit this. Cool. So this is now passing and all test cases are accepted. So the code is pretty straightforward once we have the intuition in mind. If you have any questions or doubts, please feel free to use the comment section. We'll see you in the next video.